In 3.2, we're going to discuss the transformations. So we want to make sure that we're very confident with what the basic functions are. So far, we've learned 7. So make sure you go back and review these. You want to make sure you know the algebraic representation and what the graph looks like. For these problems, I'm going to decide what the basic function is and then list the transformations and reflections. Okay? Now, first, I can see that this is a rational equation. In other words, I have a numerator and a denominator. So the only basic function that has a numerator and a denominator is my reciprocal function. If you're having problems sketching in these basic functions, give yourself some points. So at 1, it'd be 1, 1, right? And I know it's going to have an asymptote along the vertical axis and an asymptote along the horizontal axis. Okay, so I have my basic function sketched in. Now, let's look at our function. First, I'm going to look for any reflections. Reflections would be negatives in front of either the x expression or in front of the x variable by itself. So I don't have any reflections. Next, I want to look for any horizontal shifts. So, since we have no reflections, we can look at the x expression. And if it has a plus 7, that means we're going to shift left 7. Okay? Now, next we're going to look for our vertical translations. I have a minus 9. I'm going to shift down 9. So what I'm going to do is basically take my yellow function, my basic function, and I'm going to shift it, and I'm going to move it to the left 7 and down 9. And an easy way to do this, if you're sketching, is to use a reference point. So I'm going to use 0, 0 as my reference point, and I'm going to move it 7 left and 9 down. Okay? And then if you need to, you could sketch in, just kind of for your own sake, the x and the y axis for the rational function. Sometimes that helps. I sketched it in red, and I can remove my reference, and I can remove my basic function. And I'm left with my function that we wanted to graph. Let's do the next one. Our next function has an exponent of 3. Well, that's a giveaway. That means we're going to have the cube function as our basic function. So let's sketch that in. If you're having a problem sketching the basic functions, make yourself a little table. And then sketch in those points. And these are the 3 I use for the cube function. And then I can sketch in my basic function. Okay? Now, let's see how it's transformed. So, first I look for any reflections. Okay? I don't have any reflections. And I know I had a reflection because I'd have a minus in front of the x expression, or I'd have a minus in front of the x itself. I don't have either of those, so I don't have a reflection. Then I looked at the x expression. It's x minus 2. Since it's minus 2, I'm going to shift right 2. Now, this always seems counterintuitive to me because it says a minus 2, but if you graph it out with points, you'll see that it will work out that when you have a minus 2 with the x, you're going to shift right 2. And if you had a plus 2 with the x, you're going to shift left 2. Okay, next we're going to look for our vertical shift. The number by itself tells us that, and that one actually does agree with what you're seeing. If it says plus 5, we're going to shift up 5. Now, I want to sketch in my function here using my basic function. And the way I do it is I just realize that the center of my function changes from 0, 0 to 2, 5. I usually give myself a little reference, and I use a reference point. So I'm going to use 0, 0, and I'm going to shift it up to 2, 5. And then I can sketch in the rest of my graph. And we're just sketching at the moment, okay? If you needed more points, you could put more points in and build yourself a table. Okay, so I sketched in my absolute value function. If you're having problems with these basic functions, you need to really become familiar with them. An easy way is to make yourself a quick little graph, though, and that will help you to sketch it in, okay? Now, let's look at our function we have and see how it's been transformed. The first thing I always want to check for is a reflection. And I'll know there's a reflection because there'll be a minus sign in front of the x expression or in front of the variable itself. If it's in front of the x expression, we're going to reflect about the x-axis. Next, I want to look for any horizontal shifts. Horizontal shifts will be located with the x in the expression. So I'm going to shift right 2. So remember, if it has a -2, you're going to shift right. And then last but not least, I'm looking for the vertical shift, which will be up 4. Okay, so now let's graph it. Now, the first thing I'm always going to do is my reflection. So when I reflect about the x-axis, I'm just making a vertical reflection, like a mirror about the x-axis. Okay, so now I've reflected about the x-axis. Next, I want to shift right 2 and up 4. And I always give myself a reference point. I'm going to use the reference point of 0, 0 at the origin. It's going to shift from 0, 0 to 2, 4, because I'm going to the right 2 and up 4. So my reference point is traveling from here to here. I can take this function that was here, and I can just move it up here, recognizing that my vertex is shifted. And that's going to be my final function. Let me erase some of these. That will be my final function. So just to review, make sure you reflect first, and then horizontal shift, and then vertical shift. This is a square root function. I know it because it has a radical. And the index is not shown, so it's a square, it's 2. And we write that as y is equal to the square root of x. So let's sketch in that square root function, basic function now. I've sketched in the square root function. This is the basic function, right? Let's see how we've transformed it. So the first thing I want to always look for is my reflection, okay? If there's a minus in front of the expression, it will be reflected about the x-axis. But here we have a special one. We have a minus in front of the variable x itself. So we're going to reflect about the y-axis. When this happens, warning, everything goes haywire, because now you've reflected about the y-axis. Now when you look at the shift for the horizontal, it's going to be opposite of what I said earlier. So instead of a +5 meaning left 5, now it's going to mean right 5. Let me say this one more time. When you reflect about the x-axis, which is signaled by the variable having a minus sign in front of it, no longer follows the rule of thumb that I said earlier that if you have a -5, you'd move left. You'd move right. And if you had a +5, you'd move left. Instead, it moves the opposite. So now it's a +5 will move right to the 5. Okay, this only affects the horizontal. And if you think about it, that makes sense because you're reflecting about the y-axis. Okay, a horizontal shift, a reflection. Okay, now let's try this again. Let's see how this function is transformed now. I always start by looking for a reflection. Very important. And if you notice, there's a minus sign in front of the x. If the minus sign is directly in front of the variable, I'm going to reflect about the y-axis. When you reflect about the y-axis, warning, everything kind of goes haywire. So be careful. What this means now is that the rule of thumb I told you earlier about if the x has a +5, it goes left, and if it has a -5, it goes right. It's going to go the opposite direction. And that makes sense because now we're doing a horizontal reflection. So our horizontal is backwards. So now we're going to shift. Instead of normally we'd say left 5, we're going to shift right 5. One more warning. Whenever you have a minus sign in front of the variable, it signals that you're going to reflect about the y-axis. When you reflect about the y-axis, all bets are off of what we said earlier about shifting that right or left. Instead, now whatever you see is going to be the direction you're going to actually shift it. So a +5 would be right to the 5. Okay? So be really careful when you see a reflection about the y-axis. Okay, let's look at our next function. Y is equal to 1/5 x cubed. Since we have an exponent of 3, we know we're going to have the cube function as our basic function. So let's go ahead and graph that. So I graphed my cube function. Now we're going to look at our function and consider what transformations have been made. So our cube function was y is equal to x cubed. That's our basic function. Now we have a 1/5 as a coefficient. Now, when we have a coefficient that is between 0 and 1, then we're going to have vertical compression. And what that means is that our output, when we had it to x cubed, now we're going to have 1/5 of x cubed. So if you think about it, everything will just be divided by 5. So let me graph those and show you what happens. You can see it's like someone sat on the basic function and compressed it vertically. Okay? Okay, so our next problem is f of x is equal to 4 square root of x. So our basic function is the square root function. Which we know is y is equal to the square root of x. So I'm going to make a little table. I already graphed it, but just to show you that when I have an x, I'll get my output of y. And the basic function says that's going to be the square root of x, right? So if I have 0, it's going to be 0, 1, 1, 4, 2, right? 9, 3. Okay, so that gives us enough to work with, okay? Because now I want to consider my transform function. When the coefficient is greater than 1, I'm going to have a vertical stretch. Let's think what that means. So if I added a column on here, and I made the new output 4 times the square root of x. So I'm going to multiply every output by 4. So I can graph these new points. So I graphed the transform function, and you can see it's like someone stretched it vertically. And that's what happened. So we had a vertical stretch. And it was by a factor of 4. Okay, let's move on to another topic. Difference quotient is also covered in 3.2. And it is simply a general rate of change, the slope, the average rate of change that you're seeing between 2 points. So you can memorize this from the book, that the difference quotient is f at x plus h minus f of x all over h. But just realize that you're just talking about the slope. You're talking about the output when the input is x plus h minus the output when the input is x. So just like when we do the slope formula, we do the output of one point minus the output of the second point all over the input of the first point minus the input of the second point. The thing about it is we know that x minus x cancels out, and that's how they're ending up with this h by itself. Okay, so you can memorize it or you can figure it out yourself. Now we're already given f of x, which is equal to 3x plus 2. So we can replace f of x here with the value 3x plus 2. So that part of the problem is already done. So all I'm missing is the f of x plus h. Not a problem. So what I'm going to do is I'll take my equation, and wherever there's an x, I'm going to put in instead x plus h. So that it's identical equation I had right here, except for in place of x, I'm going to put x plus h. Okay? Now let's simplify this out. So I distribute 3x plus 3h plus 2. So f at x plus h is equal to 3x plus 3h plus 2. So this gives me this value. So now I'm going to replace f at x plus h with 3x plus 3h plus 2. Okay? So let's do that. So I did it. So I used my f of x plus h, and then I use my f at x. Okay? And I just write h. You're going to always write h there. Okay? Now, next, I'm going to simplify this. So all I need to do, this is a simple subtraction of polynomials. Remember to distribute that minus sign. And then I'm going to combine any like terms. Well, I have 3x minus 3x, that's 0. And I have 2 minus 2, that's 0. So I'm left with 3h over h. And I can see if I simplify this, it'll just become 3. So my difference quotient is simply 3. That wasn't hard. Okay, let's do another problem to make sure we have this concept firm. So I wrote down my difference quotient formula. I'm already given f of x. So that part of the formula I already have. I need to write down what f of x plus h is. The way I do that is I write down the exact same equation, but wherever there's an x, I'm going to put an x plus h. Okay, and now I'm going to simply expand it out and simplify it. So this is the same thing as saying x plus h times x plus h, which is x squared plus 2xh plus h squared. Okay, let's keep simplifying. Okay, so now we know what f of x plus h is equal to. Okay, and I'll replace that with this portion of the formula. So my difference quotient will be my f of x plus h in pink minus my f of x, which is my original equation, all over h. You're always going to use h for this part. Okay, so let's go ahead and the numerator is simply a subtraction of polynomials problem. So I made sure I distributed the minus all over h. Okay? Let's see if we can cancel anything out. So I see we have a 3x squared and a 3x squared. That will go away. And I have a minus 2x and a plus 2x. That will go away. Okay? So I'm left with 6xh plus 3h squared minus 2h all over h. Okay? The last step isn't hard. Just factor out an h out of the numerator. And you'll see that the h's will simplify out. And I'll be left with 6x plus 3h minus 2. That's our answer. The next couple of problems talk about finding the average rate of change. So once again, we're considering that slope idea, right? So what they're going to do is they'll give us an equation and they'll give us an interval. In other words, we're just going to take the same equation and we're going to put in an input of 2 and an input of 4 to start with. So wherever there's a 2, I'm going to replace it with a 2. And I'll get 8 plus 6 is 14. Okay? Now we're going to do f at 4. So wherever there's an x, we're going to replace it with 4. And I'll get 32 plus 12, so I get 44. So now I know the input and I know the output, right? Those go together for the first point. So it's like thinking of it like an ordered pair, 2, 14, okay? And I have a second point, has an input of 4 and an output of 44, so it's like a second point. So all we're going to do is simply find the slope. And we know how to do that. I'll label my points x and y and make this be 0.1 and this be 0.2. I know my slope formula. And I'll replace each of those values in and evaluate it for each x and y. And I'll get 15. So my average rate of change between 2 and 4 will give me 15.